Hey, what's going on? So, I was having a drink and something hit me. Yo, what do you. Okay. So, I was having a drink and this just hit me. Yo, why are you hitting me? That's for the video. Okay. So, I was having a drink and it just hit me. A lot of times, when we're solving leetcode problems, by the way, I'm going to do a brief intro. Current computer science major, about to graduate. I entered in Amazon last year. Also passed Netflix's coding loop, and I'm going to be doing some videos around LeetCode. Today's video is pretty simple though. We want to learn how to change our representation space, which is actually this. Let's make it simpler. Your goal in problem solving is not to solve the problem, but to raise your understanding of it to a level where the problem is almost trivial. Now, when you first read this tweet, just like me, you probably bookmarked it because you would never see it again. But I took it and I put it into Claude and I asked it, well, what does that even mean? Because I was drunk at the time, right? It didn't make any sense to me. And then the AI came up with this. And it says the secret to solving any problem is pretty simple. Just look at it differently. Change your mental model of it. So we're going to use word ladder. I think this is a lead code hard. Yep. And I already pre-opened the tab because I'm so drunk. If I don't do that, I might have to end up typing. That's another beer bottle. Typing in the bar, you guys might see some of the type of stuff I look at, which isn't good, right? But word ladder. So initially, when you read this, it says a transformation sequence from a word begin word to word end word using a dictionary word list. Is this? Nah, screw that. That looks confusing. Let's pick the knee code one. This is a lot simpler, right? Where is it? So you're given two words, begin word and end word, and also a list of words, word list. All the given words are of the same length, consisting of lowercase English letters, and are all distinct. Your goal is to transform this word into this word, following these rules. I'm not going to sit here and waste our time reading these rules. I ain't got time for that. But what I will tell you is initially when I look at this problem, especially from a drunk guy's perspective, I think it's a string manipulation problem. I'm talking, a lot of people might say, "Oh, it's an obvious graph." No, it's not obvious. You might be in an interview, you might get flustered, you might have a kid on your lap and you're reporting to the news. Anything could be happening, right? The world could be ending. Trump could be coming up with a new way to bomb the Middle East. Like it, anything could be happening. And you read this and you might think, well, I need to transform this word to this word, and maybe I need to validate the rest of this stuff right here. I need to validate if this word is that word, but no, it's not even that. It's really a lot simpler. And I'm gonna show you right now. So first thing, I'm gonna copy paste this, right? So let's pretend I typed it. Actually, you know what? Let's just type it. What if each word was a city, and you could drive to cities that are almost identical? Whoa, that just hits you, right? You're like, wait, hold on. Wait, hold on. Break that down for me. Great, sure, I will. So we are given, let's pick any of the solutions here. What do we have? Do we want to go from hit to cog, right? And we're given this list of words. So we've got a word list. Say that we can go from one city, right, to another city. Well, then if we look at this question as, in the context of cities, the question becomes, how do we go from this city to this city? Is it kind of getting clear to you? So hit, let's see, what does hit have a road to in there? What's close to hit? And by close to, we go back to our rules, right, where we say, well, we can transform any word to another word within that word list, provided that exactly one position has a different character. So what in here fits the one character difference rule for hit? It would be hot, right? So we can go from the hit city, let's name this the hit city, to the hot city. It's summertime. I need to get to a hot city. Then we can go from the hot city to what else? I think dot. A dot city. Look at that. That's interesting. Um, and then we can go from the dot city to the dog city. Whole lot of dogs. And we can go from dog city to cog city. Okay. Now, what we realize is we've pretty much found a path. So, was this really a string manipulation problem? I don't think so. I think this is a graph traversal problem. I think this is a shortest path problem. So, the question went from this complex, crazy LeetCode hard to, God damn it, how do I move? There we go. To this was the shortest route from the hit city to the cog city. That's literally it. That's all this question is. It's a hard, but when you break that down, you end up coming up with BFS. That's our shortest path in an unweighted graph. It's an unweighted graph because if we were to list each of these as nodes, the neighbors to each node would be any word that's directly related to it or identical, it only differs by one letter. So, originally, the tweet says your goal is to raise your understanding of it. That's all we have to do here. We look at this and we somehow understand it as some weird, possibly string. We see a lot of strings everywhere. But if we raise our understanding just a little bit and we think, well, if these are all cities, what's the shortest path from this city to this city? And suddenly, just like that, voila, we solved the problem. There's another example here. Um, find eventual safe states. And this one's also pretty similar. We trivialize it by looking at the pattern and then thinking of it a little differently. You can kind of read this, pause this, and read it, but I'm not going to talk about it. Stop right here.